Imagine being able to check for structural damage in airplanes, ships, or bridges without having to take them apart or remove samples. That's the promise of a new laser-based technique for analyzing metal that chemists at Brigham Young University are presenting at the 253rd meeting of the American Chemical Society. Metals can be weakened by mechanical, chemical, or thermal stress, but this damage isn't visible to the naked eye. That's where non-destructive testing, or NDT, comes in. This testing inspects materials without applying any extra stress, which might harm them. Typically, X-rays are used to detect microscopic cracks in metals, but that method is expensive, requires shielding to keep technicians safe, and is hard to use in the field. James Patterson and his team at Brigham Young have come up with an alternative that uses lasers. They begin by shining green laser light onto a metal sample. Thanks to a phenomenon known as second harmonic generation, the metal converts some of the incoming light into ultraviolet rays. By measuring the amount of converted light that bounces back, the chemist can tell if the material has changed following some kind of stress. The test can distinguish between metal parts that are still intact and those that have been irreversibly damaged. The chemists say their method is more sensitive than existing NDT techniques, so it could detect dangerous defects sooner. With some refinements, the technique could be especially useful in the aerospace industry, where plane parts are routinely scrapped after a certain amount of use to avoid catastrophic failure. The replacement schedule is based on the average performance of components rather than the actual condition of individual parts. Patterson's laser method could be used to check whether parts are really worn out or are still going strong, saving money, time, and material. The team is also exploring applications with the U.S. Navy. The aluminum-magnesium alloy used in Navy vessels can invisibly corrode, sometimes with serious consequences. For example, sailors have been known to step on the wrong spot of the deck, sending chunks of metal to the level below. Patterson eventually wants to create a portable version of his system to avoid such disasters. That means checking ships, planes, or bridges for structural damage could be as easy as waving a wand. For more on the latest chemistry headlines, subscribe to the ACS YouTube channel.